Hello, now we will see how the on delay type RC based electronic timer works. So you can see at this right side the on delay RC based electronic timer circuit is there. So what are the components in this circuit? So the components are a control transformer is there, which is a rating of like a 230 volt at the primary side and 12 volt at the secondary side. This is the control transformer. Then the two diodes are there, D1 and D2. Then the R1 potentiometer is there, variable resistance, and the capacitor C is there. This R1 and C is a RC based electron timer's main component, and then the relay is there and a thyristor is there. These are the main components over here. Now the question will arise that what is control transformer? What is the definition of control transformer, or uh, basically what is a control transformer? So basically the control transformer is a transformer which is used to control some electronic circuit or some electrical circuit. You can say that this control transformer is basically a low power application transformer. Here this control transformer is basically a center tap type. Okay, so this D1 and D2 is forming the half bridge circuit. Then in here, if the supply voltage is present, there is 230 volt is applied over here at the primary side, there is in the input side. Okay, so then in the secondary side of the transformer will produce the 12 volt. Now in the first half cycle, the current will flow from here to D1, then it will not go at this side, and then it will go at this side here at this junction. At this junction, these and these are the parallel circuit. So from here the current will flow from this side and current will flow through this relay and the thyristor. Now at first, if we just consider that the current is flowing this side, so current will flow through the relay, coil of the relay, and then it will not be able to pass through the thyristor, just because of if the gate of the thyristor is not turned on or not triggered, at that condition anode to cathode will not conduct, so the current will not be able to flow to the neutral from the phase. So what will happen, that the current will flow from this side and it will come through the resistance R1, that is variable resistance R1, then it will go to the gate of the thyristor. But if the gate voltage is not sufficient enough, in that case the thyristor will not be turned on condition. So here at the reduced voltage condition, the capacitor will charge. Okay, so the capacitor will charge, and after the charge completed, then the capacitor will discharge. The discharge path will be this one, to gate to cathode, then to R2 to neutral of the neutral of this control transformer. So this charging time of the capacitor the charging time of this capacitor will depend upon the this resistance, variable resistance R1. So here you can see at this left side that if VB is the supply voltage, okay, and R is the value of resistance and the C is the value of capacitance, then VB equals to VR plus VC, where VR is the voltage drop across this resistance and VC is the voltage drop across this capacitor. That is voltage across this capacitor. So VR becomes I into R, the current flowing through this resistance. So I into R plus Q by C. That is voltage across this capacitor is U by C. Okay, where Q is equals to C into VB under the bracket 1 minus e to the power minus t by RC. RC is the time constant to charge on the capacitor. Okay, this, and as the charging process is going on, so at that time VB is equals to IR plus Q by C. So if I into R, this product value is low, in that case the Q will be more to keep the VB is at constant. So current decreases and the charge increases. So if charge is increased, Q is increased, in that case the capacitor will charge quickly. Okay, so capacitor will charge more faster. So in that case, depending upon this R1, the capacitor will charge, and if the charging process is faster, then the capacitor will charge more quickly. That is, that if the charging plus discharging time, the total time, if charging plus discharging, then if the charging time is fast, then if the charging process is very quick, then the capacitor will discharge quickly. When the capacitor will discharge, at that time only this thyristor will turn on. If the thyristor is turned on, then only the current will be able to flow through the coil of the relay, then to the thyristor, to R2, then to neutral from phase. Now in the another half cycle, the D2 will conduct and the current will flow from this path to this one, through this to this one, and also in parallel with these things the current will flow also through the coil of the relay to the anode to cathode, then to neutral. Here the by varying the value of this resistance, the charging time is controlled, and uh, overall on delay setting is done with the help of this R1. Now once the thyristor is turned on, as we know that the thyristor will be turned off if the anode to cathode is short circuited by some means, or I the or if the voltage is dropped at this anode to cathode terminal. If the voltage drop down, then if the voltage drop down after a certain value, then only the thyristor will turn off. So to turn off this electronic timer, we have to just cut this circuit. Okay, just we have to cut this power supply, then only the uh, electronic timer will this timer circuit will turn off. Here you can see that the coil of the relay is here and the common terminals are here. So B1 and B2 are the normally open type, that is NO, and NC type contacts. Okay. So when the coil of the relay is energized, then B1 will become NC from NO and B2 will become NO, normally open type, from normally closed type, and that is NC. Because you can see that the initial condition is already marked, that B1 is the NO type and B2 is the NC type contact. So this is how the electronic on delay RC based electronic timer works. Thank you.